I have provided the spaces. Now check it out, like trigonometry is coming. 30%, you need to know secant, cosecant, cotangent, and further trigonometric identities, addition formula, and double angle identities. Actually, I put one question on them. And later, I will just go through with the differentiation, exponential, natural log, product rule, quotient rule, differentiation of sine, cosine, and tan, and implicit differentiation. There is no parametric differentiation coming to your exam. In integration, exponential integration, whenever you have a linear factor in the denominator, and the integration of sine, cosine, and secant square, and more on top of that, extended integration
Half
of
angle,
trigonometric functions. Yes, sorry.
half angle, half
Yeah,
angle.
yeah. And then partial fraction, very important. Inverse trigonometric function integration, very important. When you have a derivative on the top of the of the denominator, that type of integration by parts, but integration by substitution is not coming. Okay, so you can avoid it.
Mm, Not
Right?
coming?
No, in
Okay.
the class I told you, if you want to do it, I put it for external students for their practice because we did it. But for the end of term two final exams, if you want not to do this, Yani, with Mr. Omar's permission, you can avoid it. Okay. Your exam has 50 marks. It has total 90 minutes. And how many questions you will have in your exam? I think 8 to 10 questions. Um, you need to use only black or blue. Scientific calculators are allowed. Mr. Omar will provide you MF19, maybe the second page or the end of the page. In MF19, you need to know the quotient identity. Then you need to know the Pythagorean identities. Then you need to know your compound angle identities. Then you need to know the double angle identities for sine, for cosine, and for tan. In differentiation, what do you need? The standard power rule, the derivative of ln of x, the derivative of exponential function, the sine function derivative, cosine derivative, tan derivative, but this is not in our course. The derivative of inverse tan is 1 over 1 plus x squared. The product rule is uv dash plus v dv dash, and the quotient rule du over dv, and this one you already know that. Parametric differentiation is not coming in the exam, so you can just avoid it. Come to the integration. Integration, the power rule integration. If the power is not equal to -1, you will write the power rule of integration. If it is 1 over x, integration is ln of x. E of x, integration is ex. Sine of x is minus cosine of x. Cosine of x is sine of x. And secant square of x is tan of x. These two formulas are not included. It is further maths formulas. You need not to concentrate on that. 1 over x square is equals to 1 over a inverse tan x over a. You remember that I have given much more modified version that was a squared plus b squared x squared. Its integration is equals to 1 over ab inverse tan of bx over a. This was the thing which we discussed in the class. You remember whenever you have a function in the denominator and you have a derivative on the top, its integration is ln of f of x. And this is somehow an explanation of by parts, but by parts technique I have taught you. If you want to do the integration by parts, you have to make the two boxes minus this box under the integral, and then you write u, here is u dash, here you write the integration of v and the integration of v. That's the thing which we studied. So I have gone through with the MF19 formula. Mojan, did you get some confidence out of the after going through with the MF19?
Yes.
Mazen? Okay. Okay, Mazen, now you see, yani in the exam, I have set one question regarding solving the trigonometric equations. So these are the basic trigonometric equations, but you need to just look into that. Did he just do something with the domain? Yani, did he write any multiple of the x? Because I have the domain um, from 0 to 360 for x. I need to redefine my domain. You agree with that? Yani, he gave you from 0 to 360. Since I have here 2x, I need to multiply every number here in the inequality by 2. So it gives me 0, 2x, and then 720. So you will find all of your answers in this dummy domain. Agreed? Same situation here, 0x 360s. Since I have here 2x, so I need to multiply with the 2 to write my new domain. And since here he multiplied with 3, I'm going to define my domain by multiplying with 3 with every term in this sandwich inequality. What is the answer I'm going to get, man? 10 what? 360. How much is the answer? 360 times 3, 1080. Now, next thing, you need to convert secant into cosine form. So you remember the reciprocal of secant is cosine. So I'm going to write cosine of 2x is equals to 1. Here the reciprocal of cosecant is 1 over sine of 2x is equals to 4. And here,
Mr. Amir.
yeah.
Sorry to interrupt, but when is Mr. Hamad gonna do the math?
I think Hamad has made the plan on Saturday.
Okay, I'll join both.
Okay. You are most welcome, man. Okay,
Yes,
don't worry.
you,
So 6 cot of 3x. Mozen, I'm going to send the 5 to the other side. So 13 minus 5. So 6 cot of 3x. And 13 minus 5 will give me how much? 8. So cot of 3x is equals to 4 over 3. So you remember I have here cot. I need to change the cot to the tan. So I'm going to write 1 over tan of 3x is equals to 4 over 3. Can I convert it into this form? So cos of 2x, flip it, will be 1 over 1, which is 1. And sine of 2x will be 1 over 4. And tan of 3x will be 3 over 4. Mozan, any problem? Do you understand it?
Yeah, Mr. I finished this revision pack, Mr.
So you already know that. Alhamdulillah,
Yeah.
we have an idea. I'm just trying to highlight the important things. Then you look at your outputs. It is positive. It is positive. It is positive. So you remember that in a quadrant diagram, ASTC tells you your cosine is positive in the first and the second, first and the fourth. And this tells you your it is positive in the first and the second, and it tells you it is positive in the first and the third. So then you will find your acute angle. So shift cosine, make sure your calculator in a degree mod. So shift cosine of 1. Here I will write shift sine of 1 over 4. And here I will write shift tan of 3 over 4. And then you remember how to transfer the angle from the first quadrant to the fourth. We write here 360 minus shift cosine of 1. And we shift here, it is shift, 180 minus inverse sine of 1 over 4. And here is 180 plus tan of inverse of 3 over 4. Make sure, man, inverse tan of 1 is not in any quadrant, because shift cosine of 1 will give
Zero.
you 0 degrees, 180 degrees, and 360 degrees. You won't find in any quadrant. So maybe this is a trivial case. Normally it doesn't happen, but if it comes on rather than on any quadrant, it comes on lines, maybe on the horizontal line, on the vertical lines, you know how to deal with it. However, this question and this question will exactly fall in the quadrants. I think it's all fine with you how to solve the very basic trigonometric equations. Remember, again, the guy has done 2x plus 90. He has done here half x. He has done here 3x. You need to redefine your domain. So he tells you 0 to x. 0 is not included. 360 degrees. Muazzin, you need to multiply 2. So it gives you 2x and 720. Since 90 is added, so I'm going to add 90. 90, 2x plus 90, and 720 plus 90 gives you how much, boy? How much it should be? 800 and 830. Come on. 810. So this is the new domain I have found. And Mosen here again 0 to x to 360. Mr. Omer has to multiply with half everywhere to redefine my domain. So it's half x and it is 180. This is my new dummy domain. And this is 3x. You already know that how we will work on it, multiplying with 3x and 1080. Then process is same. You remember what is written here, cosecant. I'm going to reciprocate it. So this will become sine of 2x plus 90 is equals to 1. And then I will take again reciprocation. So sine of 2x plus 90 is equals to 1. And where the sine is 1, sine is 1 at 90 degrees and 270 degrees. Once you get your answers 90 and 270, you remember you will write them. You will write them and you have to go back 360 degree and go up front 360 degree steps to find more and more answers which comes within the dummy domain. So my answers are, what are my answers? 90 and 200, just 90. Within one rotation, there is only one answer. Remember, sine 0 is 0. Sine 180 is 0. Sine 90 is 1. Sine 270 is -1. And Mr. Omer is looking at 1. So within one rotation, I got only one answer because it is falling on a it is not falling on any quadrant, it is falling on a line. So this is 90 degree. So in the class, I told you how you can get more and more answers within this option. You keep on adding 360 degrees and get more and more answers until you go out of the range. So I'm not gonna, do this step again and again. You need to understand 90 plus 360 will give you another answer. Then plus 360 will give you another answer. I think there are two more answers. I just wrote it here. You need to just simplify and try to convert it into basic trigonometric equation. So 4 minus 3, since my subjective term is negative, I'm going to send it to the right hand side. 3 cot of half x is equals to 1 is equals to 3 cot of half x. So Muazzin 1 over 3 cot of half x, and I'm going to reciprocate it. 3 over 1 is equals to tan of x over 2. And then you remember how to solve the equation. And if in the exam this type of a question comes, you know that you have to make secant 3x as a subject. You need to send the 5 to the right hand side, square root of 2 plus 5, and secant of 3x is equal to square root of 2 plus 5 over 2. And now I want to convert secant into its reciprocal, which is cosine of 3x. And so I write 2 on the top and square root of 2 plus 5 down. then you know I have my positive answer. So cosine gives positive answer in the first and the fourth, and you will carry on the procedure. Don't forget, in the dummy domain, when you get your answers, you need to get all possible answers within the dummy domain. And the moment you get your final answers, all answers will be equals to 3x. And then you have to divide every answer by 3 because
Mr.
my answer, yes.
Sorry. Can I use the calculator? Cosine 3x equals 2 over square root 2 plus 5 and then write
Yeah,
the
you
answer?
can you can use it. But the way I have taught you, you need to write all possible answers from 0 to 1080. You understand my point?
108.
Yeah, 1080.
So
Okay,
the
let me do it in front
no
of
no
you. Okay.
do it not using the calculator, without using the calculator.
Yeah, without calculator, I'm just writing it square root of 2. I want to get the acute angle. Okay.
Yeah, and then what? Yeah.
So the acute angle comes to me 71.83. Got it?
Okay.
71.83. This is my
So
first quadrant, and since it is positive, I'm also expecting my answer in the fourth quadrant. 360 minus acute
Well,
angle, 288.17. 288.17. Now, do you think these answers are within the dummy domain, or more answers are also possible because
more
your
answers
dummy domain
also.
is very big? So keep on adding 360 degrees. So I'm going to write 71.83 plus 360. I got a new answer, which is 431.83. 431.83. It is still within the range. Can I again add 360? Still, I'm within the range, 791.83. Can I again add 360?
Yes.
Now you got a bigger answer than 1080. So shall I include it? The answer is no. Okay. Can I apply the same procedure on 288.17 plus 360? I got 648.17. Shall I go for furthermore addition of 360 degree? I got 1008.17. 1008.17. Do I need to add again 360? My answer is bigger than 1080. But can I say these are my final answers? No. All these answers are basically equals to what? They're equals to 3x. If in the exam you stop here, you will lose 1 accuracy marks. You have to write x is equals to 71.83 divided by 3. What? 31.83 divided by 3. Mazen, you understand my point? Do you understand it or not?
Yes, yes.
Okay. So solving simultaneous equations are okay. Now come to the sketches. In sketches, you need to understand the opposite of cosecant. The opposite of cosecant is sine. So a student needs to know how to sketch sine of 3x. So sine of 3x means you are going to have 3 waves. You are going to have 3 waves from 0 to 360. So your period is 360 divided by 3 will be 120. And 120 further divided into 4 parts, 1, 2, 3, 4. So this is 120. Agreed? And then 1, 2, 3, 4. This is next is 240. And then 1, 2, 3, 4. This is 360. Let us try to draw the sine graph.
Three periods.
It has a period of 3, yeah. Period is not 3, frequency is 3.
It's 1, I know. I know period is not 3, but
okay, can I just make it like this so that I can make an accurate diagram? And in between, the period must be equally divided into 4 equal parts. So did you see that I have divided the period into how many parts? 4 equal parts.
3.
Yeah, Sheikh, four equal parts. Did you see?
4
equal parts. Yani, start from here. Look. 1 wave.
Yes.
2 waves. 3 waves. Agreed? But this is the sine graph. I'm going to draw the opposite, the cups and the caps. Remember? I'm ready to draw the cups and the caps. Where the zero is happening, the zero is happening here. So here I will be getting asymptotes. So zero is happening at 120. Zero is happening at this point. Zero is happening here. Zero is happening here. Zero is happening here. So all the values where the zeros are happening, because the reciprocal of zero is infinity. You remember? Yani, the reciprocal of zero is infinity. So you have to draw the vertical asymptotic lines. So Mr. Omar is ready to draw the graph now. Bismillah ar-Rahman ar-Rahim. Ready? See? Cup and a cap. Can I erase now? Do you understand? This is your, right here, this is 1 and this is -1. This is a graph of cosecant effects. Easy peasy?
Inshallah.
No, tell me where you don't understand it.
No, it's not that I don't. Yani, why did you draw it like this opposite, like a parabola?
Oh man, so it means that you did not attend. I was thinking you know this. You didn't attend my sessions. The cosecant and the sketches. I think you did not attend
No,
my session. Oh
no.
man, now I need to repeat everything. That's why, guys, I'm always telling you, please ask me if any problem happens. Anyways, I'm trying to explain you again. This is a sine graph, okay? This is a sine graph. Now, when I want to draw the opposite of sine graph, which is the reciprocal of sine graph, it is cosecant graph. So I'm gonna just up and down. Where is infinity happening? Sorry, it is 0. It is 0. It is 0. So all these
This is
points I need
here,
to draw
this.
the vertical lines, okay? I think it's best way to draw the sketches on the grid. That looks better. Right? Now, since it is a cap, check that. Which one is a cap? This one is a cap. I will make an opposite of this. What it should be? Like this.
Opposite to this,
The
you
blue
write
one is
this.
for
Okay.
the blue one is for cosecant. And the red one is for
Sine.
oh, lovely. But you need to carry on. This is just like I think 0 to 30 degrees. No. I want to move till 360 degrees. You got my point. So this is what? 120 degrees.
This is one period.
Yeah, one period, which is 90. Because the actually sine graph period is
120.
360, but this is sine 3x.
Yeah.
And cosecant
Divided
3x.
by, yeah, so a factor of 1/3.
And will you continue like this till 360?
Yes, why
Okay.
not?
Shall I move on?
Move on.
Okay. Secant is the reciprocal of cosine. So you need to draw the graph of cosine first, and then inshallah you will able to draw the secant 2x graph. Do you want me to discuss this one or to go to the next?
Solve it.
Okay, you want to draw it. But I will draw it roughly, okay?
Okay.
So what's the frequency? It's 2. Yani 2 cycles
يعني
we
one
will
of
see.
uh,
So it means that
180.
the complete wave will be formed, the complete cycle will be formed for the secant will be after 180. So 2 waves we will see inside it. Let's check it out. I'm going to draw the cosine graph. So half is 180. The period is 180. I need to divide it into how many parts? 4 parts. Until 360 again, how many parts? 4 parts.
Well,
Clear?
okay.
So I'm going to draw the graph for the cosine. So this is cosine graph. The maximum value 1 and minimum is -1. Cosine always starts from 0 is
1.
here. Yeah, very good. 1. And then like that. Got it?
9. Yeah.
So this is a cosine graph. And then in the same way, can I make the other? Done. This is the cosine graph. Now where I'm getting 0 degrees, come on, go ahead. Where is
45.
0? This is 0.
Yes.
This is 0.
Index.
This is 0. This is 0. Agreed?
Yes.
Now draw the opposites. Clear? Mozan, is it fine?
Mm.
So the blue ones are your cosecant graphs. And the green ones are cosecant. It is cosine of 2x. And the blue one is secant of 2x. How do you feel now? Confident?
Good. Good. Yes.
Okay, good. Let's go to come out of sketches. Now we go to the trigonometry. Look, in trigonometry, the question which I have put in the exam, I want the following things from you. You need to know that 1 plus tan squared theta is always equals to secant squared theta, which is the Pythagorean identity, right? So stick to it.
Yes.
Another one is 1 plus cot squared theta is equals to cosecant squared theta. Maybe I will ask you to use both of them in the question, okay? So 1 plus cot square, and the first one is, which you took it in A as sine square plus cosine square theta, it is equals to 1. These are the 3 Pythagorean identities. If you forget them, you can refer to the MF 19. They are provided over there. Clear? Now, examiner is saying here he has a cot square, cot and cosecant square. So definitely I'm going to convert cosecant square into cot form. Do I have any identity? The answer is yes. 1 plus cot squared theta is equal to cosecant squared theta from the Pythagorean identity. So I'm going to just remove cosecant square, and in place of cosecant square, I will write 1 plus cot squared theta. And here I keep 4 cot squared theta minus 2 cot theta. Any question? Now the time has come to simplify them. So 4 cot squared theta minus 2 cot theta. Open the brackets. So 3 plus 3 cot squared theta. Now send them to the left-hand side. So 4 cot squared theta minus 3 cot squared theta minus 2 cot theta minus 3 is equals to 0. Now can I simplify them? It will be cot squared theta minus 2 cot theta minus 3 is equal to 0. Yes, Moazan. Does it look like a quadratic equation in cot theta? Answer is yes, it is a quadratic equation in cot of theta. Now I need to make sure my calculator is in a degree mod, and I have to go to the equations, polynomials. I want to solve like a quadratic equation. Okay, enter 1. The coefficient of cot square is 1. Enter 1. The cot theta coefficient is -2. And then -3. First answer is 3. So first answer is 3. Second answer is -1. Now both of these answers are not equal to theta. They are equal to this thing which is written here, cot theta, because this is quadratic in cot square theta. Cot theta, sorry. It is quadratic in cot theta. So I'm going to write both answers equals to cot theta. Now, did you see that it turns into a basic two trigonometric equations, which I have just discussed in the beginning. Now, cot theta is equal to 3 can be written as tan theta is equals to 1/3. And here tan theta is equals to 1/-1, yani -1. Now, it's a positive answer. So you're expecting your answer in the first and the third. Inverse tan of negative, you're experiencing your answer into what? This and this. I need to get my acute angle, inverse tan of 1/3, and then this answer will be 180 plus inverse tan of 1/3. And here, acute angle is inverse tan of 1. Here, 180 minus inverse tan of 1. And there, 360 minus inverse tan of 1. I hope it clears to you. And the range is given to you from 0 to 360 degrees. So this quadrant, this quadrant, this quadrant, and this quadrant. Was there any question?
No.
Wallahi easy.
Wallahi easy. This one is
Oh,
easy.
shukran. Shukran. Okay. Now we have here cot, and here we have tan. I think the best way is change the tan cot to tan. So I'm going to write 3/tan plus 2 tan is equals to 5. I want to get rid of this tan, so that's why I need to multiply every term with tan. So, ready? I'm gonna multiply with tan theta here, multiply tan theta, multiply tan theta. Now tan theta cancel with tan theta, what is left to me? 3 plus 2. Tan theta times tan theta is tan squared theta, and this is 5 tan theta. Now it looks like a quadratic equation in tan. Can I rearrange it? 2 tan squared theta. Send this one to the left. Minus 5 tan theta plus 3 is equals to 0. And then I know how to solve this trigonometric equation. I need to enter 2, enter -5, enter 3 into the calculator. First answer 3/2. Second answer 1. And both answers are equals to tan theta because this is quadratic in tan theta. And you remember you are getting a positive answer. So you're expecting your answer into first and the third quadrant as per ASTC rule. And here I'm getting a positive answer. It means again, I'm getting first and the third quadrant. I need to get my acute angle and then transfer the acute angle to the third quadrant, 180 plus inverse tan of 3/2. Inverse tan of 1 and 180 plus inverse tan of 1. Is it easy? No objection? So Mohsen, next question is prove the identity. We have a left-hand side and we need to prove our left-hand side is equals to the right-hand side. So I'm going to write my left-hand side tan theta over 1 plus secant theta, 1 plus secant theta over tan theta, right? Now I need to write the quotient identity for tan and for secant. Tan is equals to what? Sine over cosine, and this is 1 plus, and secant is 1 over cosine. And 1 plus secant theta is 1 over cosine, and tan theta is sine theta over cosine theta. Now, can I multiply all the terms with cosine theta just to get rid of the fractions? And same thing here. Multiply everywhere with the cosine theta. Now cancel this cosine with this. Cancel cosine with the cosine. I'm going to get sine theta over cosine theta plus 1. And here cosine theta plus 1 over cosine cancel with cosine, and I get just simply sine. Can I take the LCM? Yani I have two fractions and there is a plus sign in between. What did you study? You need to multiply sine with the sine. It gives you sine squared theta, and then you have cosine theta plus 1 multiply with cosine theta plus 1. In the denominator, you have cosine theta plus 1 is going to multiply with sine of theta. Open the brackets. Sine squared theta, cosine squared theta, cosine theta, cosine theta plus 1 over, no need to open the brackets, so cosine theta plus 1 and sine of theta. Mohsen, Pythagorean identity tells you sine square plus cosine square, it is equals to 1. Cosine theta plus cosine theta, it is 2 cosine theta and plus 1. Can I write this 1 plus 1 as 2? Don't open the brackets in the denominator. So 1 plus 1 is 2. So 2 plus 2 cosine of theta over cosine theta plus 1 sine theta. Next step, take the 2 common. When I take 2 common, I will be left with 1 plus cosine theta. And down I have cosine theta plus 1. Are these two factors same? They will cancel. And finally, I will get 2 over sine theta, which is equals to the right hand side. Is it the same thing, guys? Mohsen, are you with me? Hello.
Yes, sir, we can hear you.
Okay. So now I'm going to go to the question number 7. This type of questions are very important for the exam when we have a square. And here the examiner has written secant theta minus tan theta. I remember there is a question like that, so be careful about it. So maybe examiner will write over there tan cot theta plus tan theta. whole squared. Yani if he writes a square on the top, you need to be very careful how the square will be opened, right? And you need to write the same bracket how many times? 2 times. Omar, same bracket, how many times? 2 times, because the square tells you that this bracket is multiplying 2 times. And I multiply them now. Secant theta times secant theta will be secant square theta. Secant theta multiplied with this one is minus tan theta and secant theta. Then tan theta multiplied with this one is minus tan theta and secant theta. Then minus tan and minus tan, minus time minus is plus tan squared theta. I hope it clears. Now, minus tan theta secant theta and minus tan secant theta, they are the same things. We need to add them up and it will give you what? Secant square theta minus 2 tan theta secant theta plus tan squared. Am I done with my work? Let me check. Oh man, I want to get the answer like this. Quite interesting. I want to check that because I'm standing nowhere. I don't know how to move further because tan square theta is equals to secant square theta minus 1. I just put a highlighter on it that I can, Mr. Omar, move till now to this thing. Why not? I can start moving from my right hand side, which is 1 minus sine of theta over 1 plus sine of theta. It's up to you guys. I can easily make here sine theta or cosine theta. Maybe students are saying, no, Mr. Omar, can you just try to simplify it furthermore? For example, secant square and tan square, they have a special relationship between them. I can write tan square plus 1, or if you want it right, you can write 1 over cosine square theta. And this one, how can I write? 2 sine theta over cosine theta, boys. And this is 1 over cosine of theta. And tan square is what? Sine square theta over cosine square theta. Wow. So 1 over cosine square theta minus 2 sine theta over cosine times cosine over cosine square theta plus sine square theta, boys, and down is cosine square theta. Now, am I having same denominator, boys? I'm going to write a single denominator, cosine squared of theta. Now I have 1 minus 2 sine theta plus sine squared theta. Agreed? And my friends, allow Mr. Omar today. This thing is equals to, don't cry now when I write. This thing is equals to sine theta minus 1 or 1 minus sine theta wholes. Can I write it like this? 1 minus sine theta whole square. Allow me to write it, because if you open 1 minus sine theta whole squared, boys, 1 minus sine theta, 1 minus sine theta, believe me, you will get 1 minus 2 sine theta plus sine squared theta. Same answer will come to you. So Mr. Omar said that the top thing can be written as 1 minus sine theta whole squared. And in the denominator, I'm going to write cosine square theta by using the Pythagorean identity, which is cosine square theta is equal to 1 minus sine square theta. Now, Kudrat formula, you remember, a squared minus b squared, it should be written as, yani on the top, it is 1 minus sine theta. Same bracket should be written 2 times, 1 minus sine theta and 1 minus sine theta. However, in the denominator, I will write a squared minus b squared is equal to a minus b and a plus b. So 1 minus sine theta and 1 plus sine theta. So boys, this is cancelled. and I got 1 minus sine theta over 1 plus sine theta as my right hand side. So suppose if you get in the exam cot theta plus tan theta whole squared. So don't worry, guys. You need to write the same bracket cot theta plus tan theta. Again, you write cot theta plus tan theta. And then you need to multiply them. Cot times cot is cot squared theta. Cot, this one is cot and tan theta. And then tan times cot. Okay. And then tan times tan is tan square. Then cot square theta. They are the same numbers. So I'm write 2 tan theta and cot theta plus tan squared theta. And then after that, my friends, you can write tan cot square is equals to what? It is equals to cosine squared theta over sine squared theta. It is 2 sine theta over cosine theta, and this is cosine theta over sine theta, and this is 1 over sine squared theta. Now, this is cancelled, and you will be left with cosine squared theta over sine squared theta plus 2 plus 1 over sine squared theta. If you want to further simplify it, you can write here sine squared theta on the top and sine squared theta in the denominator. Then you will have sine squared theta down, cosine squared theta plus 2 sine squared theta plus 1. And later on, you can simplify it furthermore according to the requirement of the examiner. But it's not very hard. You have to tune up your algebra skills. If your algebra skills are okay, then you won't have any problem in solving such type of questions. Is it fine, boys? Now I'm gonna move to the next trigonometric identity. It's I need to prove the left-hand side equals to the right-hand side. I have left-hand side cot squared theta cosine squared theta minus sine squared theta. A cot square can be written as, come on, sine squared theta over sine squared theta. And this is cosine squared theta minus sine squared theta. In the denominator, I have just 1. Okay. And what I'm gonna do now, guys, I'm gonna just write here cosine of 4 theta minus sine of 4 theta over sine squared of theta. So I have a stop here, and then this is a square minus b square. I can write it as cosine square theta plus sine square theta one time, and cosine square theta minus sine square theta. And in the denominator, I'm just getting sine squared theta. And now everyone knows this is Pythagorean identity, which is equals to 1. So I will be left with just this thing, cosine squared theta minus sine squared theta over sine squared theta. Then after that, Mosen, cosine squared theta over sine squared theta in a splitted form, and sine squared theta over sine squared theta. Now this is cancelled. It will give you 1, and this is becoming cot squared theta. And that is the result which I wanted to make. Then question number 9, if you see, he has given it to us. How many students they are with us, please? Let me check. I think Umar is with us and Moazan is with us. This is compound angle
Yes,
identities. Yeah, this is compound angle identities, which you took it with Mr. Hamad as well, which is cosine A, cosine B. So I'm gonna write A is cosine of A plus B, which is 10 plus 20 degrees, and that is equals to cosine of 30 degrees. And from the calculator, it is square root of 3 over 2. If you wanna see the B part, it looks like again, a compound angle identity, which is equals to sine of A minus B, yani 75 minus 45. So it turns into sine of 30 degree, which is equals to half. If you look at the C part, the C part is again compound angle identities, and which is equals to tan of A minus B, which is 103 minus 58. So 103 minus 58 gives you 45. So this is tan of 45, which is equals to 1. And now if we look at the D part, tan of 75, 1. Can I write it in a tan form? The answer is yes, because tan of 45 degrees, it is equals to 1. This is tan 75 written by him. So it's better to write here because the guy has not written. Let me write it in another form so that you don't get confused. It is written by the examiner. 1 plus tan 75 is better for us. And here it is. He is writing here tan 75 minus 1. So I'm going to write it here 1 minus tan of 75 and write the minus sign outside because I have to have here 1 first. So that's why I took the minus sign common from them and write the minus sign outside. Then it would be easier for me. Minus, this is tan of 45 plus tan of 75 over 1 minus tan of 45, which is 1. No need to write it. So this is 1 and tan of 75. This is basically equals to minus tan of 75 plus 45 and minus 45 plus 75 gives us 120. And then give this command, Omar, to the calculator, and calculator solve for you the third form 120 minus square root of 3. So this gives you minus square root of 3. Final answer is square root of 3 after the multiplication of minus with the minus. In question number 10 of trigonometry, you guys can see that I have to apply the compound angle identities. First, this thing has to be opened up. So sine alpha cosine beta plus cosine of alpha sine of beta. So this is the expansion of this. Then I need to expand, Omar, this one, sine of alpha cosine of beta minus cosine of alpha and sine of beta. Then we check that, is there anything which can be cancelled out? So this is cancelled. So sine alpha cosine beta, sine alpha cosine beta, which is equals to 2 sine of alpha and sine of beta. So this is done. Next, if we want to go to the B part, in the B part, he says cosine of alpha plus beta, okay, plus I wish it works. There is a glitch. Hello, boys. Are you there?
Yes, mister, we can hear you.
Because there is a glitch, so I just need to sort it out. I don't know. It got stuck. Okay. So as you see, cosine of alpha plus beta plus sine of alpha minus beta. Omar, I'm going to expand cosine of alpha plus beta, which is equals to cosine of alpha cosine of beta. If you have a plus sign, then you write minus sine of alpha sine of beta. Then expand this one, cosine of alpha cosine of beta minus sine of alpha and sine of beta. Now you have this result common, same. I'm going to write here 2 sine of alpha sine of beta and then this result, which is equals to minus 2 sine of alpha and sine of beta. I need to take 2 common from them. The cosine of alpha, cosine of beta minus sine of alpha, sine of beta. And that is equals to cosine of alpha plus by using the compound angle identity. So 2 parts are done by me, and then examiner has also set a C part for you. He said that sine of alpha minus beta, cosine of alpha minus cosine of alpha minus beta, and sine of alpha. I'm trying to use the applications of compound angle identities, and I'm assuming that you guys have already an idea about it. That's why I'm solving it fluently. And anywhere you get stuck, please stop, Mr. Omar. Sine alpha cosine beta minus cosine alpha sine beta is the expansion of this thing. And then cosine of alpha cosine of beta plus sine of alpha and sine of beta. Then open the brackets, sine of alpha cosine of beta cosine of alpha minus cosine of alpha sine of beta cosine of alpha, because this is multiplying with both of them, minus sine of alpha sine of alpha cosine of beta, and then minus sine of alpha sine of square of alpha and then sine of beta. Is there any way that we can simplify the expressions? I have cosine of alpha sine of beta. No, there is no way that I can simplify my expression. Only this one can be cancelled. So final answer will come to me like this, minus cosine square of alpha sine of beta minus sine square of alpha sine of beta. I can take sine of beta common and minus sine of beta common, and I will be left with cosine square of alpha plus sine square of alpha, and that is equals to 1, yeah, Umar. And my answer will be minus sine of beta. When inshallah at home,
okay.
you will be practicing,
Yes,
you can take the reference.
of course.
Yes, please. Please ask me
Yes,
if
of
there is
course,
any
Mr.
confusion, any ambiguity, any problem. Please
Yeah,
do let me know.
I'll send you, Mr. on like WhatsApp if I need extra help or I don't understand something.
Okay. Okay.
Okay.
Now we are about to finish the questions here in trigonometry, as the guy has given you, for example, the double angle identity here. This is the equation. So we have like 6 questions where the examiner has used the double angle identities and use them in the equation. So let me try to solve the first one. He said sine of 2 theta, it is equals to cosine of theta. So what did we learn? The sine of 2 theta can be written as 2 sine theta. This is the double angle identity. I'm using it now. Cosine theta, and bring the cosine theta to the left. So minus cosine theta is equal to 0. Now I'm going to take cosine theta common. When I take cosine theta common, so I will be left with 2 sine theta minus 1. So either cosine theta is equal to 0 or 2 sine theta minus 1 is equals to 0. Now 2 sine theta is equal to 1 and sine theta is equals to half. Cosine is 0 where it is 0 at 90 degrees and 270 degrees. As far as sine theta is half, so theta is 30 degrees and 180 minus 30 will give you 150. So these are the 2 answers for this particular question. So I'm done with this one. In the same way, inshallah, I will send you the solutions for the B, C, D, E, and F. In this way, we can pace up our work. The question number 12, which I gave it to you guys, we need to prove our left-hand side equals to the right-hand side. I'm gonna write sine of alpha over cosine of beta plus cosine of alpha over sine of beta. Now I'm gonna draw the big line, cosine of beta, sine of beta. So here sine of alpha, sine of beta plus cosine of alpha, cosine of beta. And on top of that, this thing is equals to what? Sine alpha, sine beta plus cosine alpha, cosine beta. That is equals to cosine of alpha minus beta. And in the denominator, it is sine alpha, sine beta, sine alpha, cosine beta. And I need 2 here. Multiply 2, multiply up with 2 and 2 down. So this is 2 cosine of alpha minus beta. What is this equals? It's a double angle identity, and that is equals to sine of what is that? Sine of alpha plus, or you can write, because both of them are betas. So this is sine of 2 beta, which is equals to the right hand side. After that, question number 13, if you can see, guys, we need to make the left hand side equals to the right hand side. We have your left hand side secant of 2 theta minus tan of 2 theta. Now secant of 2 theta can be written as 1 over cosine of 2 theta, and tan 2 theta is sine of 2 theta over cosine of 2 theta. Since the denominators are same, we'll draw the big line and just write copy cosine of 2 theta. In the numerator, we have 1 minus sine of. Now, can I replace 1 by sine squared theta plus cosine squared theta, which is the Pythagorean identity? And the double angle identity says to me, Omar, I'm going to write here minus 2 sine theta cosine theta whole over. And in the denominator, I'm going to write cosine of 2 theta, the mixed version, because cosine 2 theta has 3 forms. Maybe Mr. Hamad has taught you cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. So I'm going to use, Omar, this one. So cosine squared theta minus sine squared theta. Now, my friend, this thing is equals to sine theta minus, or cosine theta minus, and write it as cosine theta minus sine theta whole square. Wallahi, if you open the square, you'll get the same answer on that. And here the Kudrat formula, you remember the difference of 2 squares. In Kudrat, they use a lot. Cosine theta minus sine theta and cosine theta plus sine theta, a lot. Okay, so one of the bracket is cancelled with this one, and that is equals to cosine of theta minus sine theta over cosine theta plus sine theta. You can check it out that this is given here. So imagine in this small session, I could able to finish with you the whole trigonometry. And then after that, we have differentiation. In differentiation, you can check that this is exponential function. When you take the derivative, same answer will come to you. Same answer. But then the further derivative of minus 2x is minus 2. So final answer I can write minus 2 e raised to power 2x. If you go to the next one, suppose this one, derivative, same answer will come to you, e raised to power 5 plus x. The further derivative of 5 plus x is just 1. So no need to mention it, just copy 5 plus x. I can write this answer directly. So dy by dx is equals to 9 e raised by 3x. Omar, further derivative of 3x is 3. And I'm going to get 3 times 9 is 27 e raised by 3x. In the d part, he says I have to apply the derivative minus at 8 as it is, e raised by square root of x as it is. But what is the derivative of square root of x, which is half goes back and then minus 1/2. That's the answer for this question. If we go to the e part, we have two terms. So when I try to go with the dy by dx, 3ex as it is, minus 2 e raised by 4x times with the 4. And then finally, I will get 3ex minus 8e4x. If you look at the f part, dy by dx, it will be half as it is, e raised by minus 8x as it is, and the further derivative of minus 8x is minus 8, and then 2 cancel with minus 8, it gives you 4. So minus 4 e raised by minus 8. And in the same way, inshallah, when I will share with you my handwritten solutions, inshallah, already the answering keys you have with you, it will give you a very good practice for the revision of final exams. Sometimes the examiner in the exam can ask you about the gradient of a tangent. Basically, gradient means you need to find dy by dx. So the dy by dx of this thing is ex is as it is, minus 6. It is power rule, power goes back from the power, you subtracted 1. And he said you have to substitute x is equal to 1. So e raised by x minus 3 x raised by minus 1/2. Just plug here 1 in the place of x, you need to plug 1. So what I'm going to get, e raised by 1 minus 3, 1 raised by minus 1/2. This will be left as e minus 3 because the power of 1, anything is always equals to 1. So 1 times 3 is 3. My final answer is e minus 3. No need to evaluate it because the examiner wants the answer in the exact form. Then we have another thing which is coming in the final exam, the logarithmic functions. The derivative of a log function, you need to understand how it is found. Part A is pretty simple, dy by dx. 8 is a coefficient, you keep it. Okay, Omar. And then Ellen tells you, you need to reciprocate your argument.
Yes,
So 1/3x, just whatever the argument you see, you need to reciprocate that one. And then don't forget the chain rule says you need to take the further derivative of 3x, which is 3. So 3 cancel. So I'm going to get 8/x is the final answer. In the B part, y is equals to ln of 2x cubed. When I take dy by dx, I need to take the reciprocal of 2x cubed, which gives me 1/2x cubed. But here your work doesn't stop. You need to take the further derivative of 2x cubed, which is 6. 3 times 2 is 6x squared. Cancel 2 with the 6, which gives you 3. And square cancel with x cube, and you will get 3/x in the denominator. C part. dy by dx. Ready? You have ln, you need to reciprocate it. So I'm going to write 1/2 minus 4x. Once you do this, you need to take the further derivative of 2 minus 4x, which is just minus.
Oh, mister, we got the one from y, right?
Which one?
We got the one for the dy over dx.
Yeah, because
From
you remember
y.
that the y becomes dy by dx because I'm
Yes.
finding the derivative, all right?
Yes.
Next onwards, it's 6 ln of x/2. I have a session after this. I'm going to stop it here. And the remaining parts, inshallah, in a video form, tomorrow, you guys will receive after Juma prayer, inshallah. Okay, so you guys can
Okay,
watch my
inshallah.
lesson repeatedly.
Thank
Every
you.
question I will explain in detail to you. Okay, so don't worry, guys. Inshallah, Mr.
Okay.
Omar is taking care of you. If any problem happens, do let me know that Mr. Omar, we have an issue.
Of
So
course.
inshallah, I'll try to sort it out. Okay.
Inshallah.
So 1/x,
Okay.
2 goes up. So inshallah, you can go now. And we are done for today. Mohsen, do you have any question? Mohsen, are you with me or you're gone? Okay, thank you guys. Bye bye. Assalamu alaikum.
Thank you, Mr.